right, quickly, ladies and gentlemen, this question was sent to me by the same student. Okay, I think it's Waec question as well, under electricity. Okay, so we have to quickly take a look at how we can solve this. Okay, very fast, and then we have to move on quickly. Now, a galvanometer of resistance 50 ohms, which gives a full scale deflection for 1 milliamp, is to be adapted to measure current up to 5 amps. All right, calculate the resistance of the resistor required. 2, if the resistor is made up of a material of cross-sectional area this and resistivity is this, ohm meter, calculate its length. Very good. So what we're going to do is to bring out the value. Galvanometer, the resistance in galvanometer is 50 ohms. The current in the smaller value is 1 milliamps. The current in the maximum value is what? 5 amps. Now 1 milliamps is actually the same as what 1 times 10 to the power minus 3. All right, so what we're going to do is to look for arrow shunt. Okay, the shunt is question mark, what we have here. And your from Ohm's law, your resistance is equal to voltage over what? Current. Okay, the voltage over current, and your voltage is equal to what? The I maximum times the resistance given to you for the maximum over the current. Okay, the total current given to you, and of course that's going to be I maximum. Obviously that's going to be I maximum minus I little I. Okay, I call it little I. Okay, all right, so if I'm to go by that, I'm going to get this as 50. We're going to get 5 times 50. All right, 5 times 50, because the current here is 5 amps. Exactly, look at it. The current is 5 amps, exactly, and the voltage from the galvanometer is 50 ohms. So we're going to get this, okay, all over the current maximum again, which is 5, minus the smaller current, which is what? 10 to the power minus 3. Okay, that is 1 times 10 to the power minus 3, same thing, right? Okay, so on that note, we're going to get 250 divided by this value, which is about 4.99. all right, thereabout. Can we check that? Let's check that. All right, so what is 5 minus 0.001? all right, and that gives us 4.999. okay, 4.999, because your 0.001 is the same thing as 10 to the power minus 3. all right, so on that note, we're going to get 4.999, right, which we got here right, so far, right? Okay, now what we're going to do now is 250 divided by 3.9, the 250 here. All right, let's do 250 divided by 250, actually 250 divided by 4.999. okay, though that's an error. 4.999. okay, so that would give us 50.0. That will be because of 50 ohms, right? So that is actually because of 50 ohms. Your arrow shunt is equals to 50 ohms. Make sure you have your pen and paper writing, right? So your arrow shunt, okay, here your arrow shunt will be equal to 50 ohms. all right, I've gotten that. So what we're going to do now is to come back and go to Roman figure 2. Roman figure 2 part of the question says, if this is now to calculate the length of the wire. all right, and so for us to solve that, our actually resistivity, all right, so our resistivity is something of this nature, right? That is more like the symbol for resistivity, equals to arrow A over L. okay, obviously this resistivity equals to the resistance rather, times the area given to you over the length, this L, right? So we're looking for the length, so we're going to make L resolve the formula. If you have to make L resolve the formula, L will be equals to what? This will be equals to resistivity over what? The resistance times area over what? Resistivity. all right, so your length is equals to what? Resistance times area over what? Resistivity. okay, that would give us that, right? So of course we already know our values, right? Our resistance here is 50 ohms. okay, we're using this as 50 ohms, and then the area is given to us. Let me bring them out, okay, so that we do not waste our time. all right, so we got the values this way, right? The length is given to us, okay, the length is given to us 50, which is the resistance. Look at the formula. The length equals to RA over what? Resistivity. So the resistance is, which we calculated as 50 times 4 times 10 to the power minus 4. Please, this is centimeter square. all right, this is centimeter square. So what we're going to do is to convert it to a meter square, and then the resistivity is 2 times 10 to the power minus 6 ohm meter. all right, so then I need to convert centimeter square to meter square. Remember, 100 centimeter make 1 meter, right? So your 10 to the power minus 4 centimeter square would be equals to this will be equals to 50 times 4 times 10 to the power minus 8, because that would be like 100 times 100 in negative form give us what? 100 raised to, that is 10 to the power minus 4 times add this minus 4 to it, minus 4 minus 4 will give us what? Minus 8. Is that clear? Okay, you can take your time to find that out. All over 2 times 10 raised to the power what? Minus 6. Alright, so what we're going to do is we calculate this value 50 times 4 or 2 divide 50, of course you can do, or you can do 2 divide 4 here to give us 2. Then that 2 times 50 is going to give us 100. So we're going to get 100 times 10 raised to the power what? Minus 8. 10 raised to the power minus 8, this is 10 raised to the power minus 8 over 10 raised to the power minus what? What was that? Minus 6 here. Alright, make sure you get your pen and paper. So what we're going to do now, if you take everything to standard form, that will give us 10 raised to the power 2 times 10 raised to the power minus 8 over 10 raised to the power minus 6. Is that clear? Very good. Now if you take up the fraction up there, the numerator up there, that gives us 2 and minus 8 give us what? Minus 6. So this is going to give us 10 raised to the power minus 6 divided by 10 raised to the power minus 6. Alright, is that clear? That is it, right? 10 raised to the power minus 6 divided by 10. Now of course if you divide that out, you're going to get what? 1 as a value. So we're looking for the length. The length of the wire would be what? 1 meter, obviously. All right, that would be 1 meter. Is that clear? So take your time to do your revision and then come back to me and tell me what you saw as the answer. Give it to, there's the answer, give it to the question. Please let me know so that we can compare and see what we got as our answer, right? So this is 1 meter. So I believe you have understood this, or what you can do is to please replay the video if you don't understand this, until you get the full understanding of what you have gotten. And if there's any question, please reach out to me and let's see what we can do to take care of it. All right, God bless you. This is Dr. Sam K. I'm going to be out for now. Okay, bye bye for now. God bless you.